Hey guys, how's it going? So we're doing question 5 on our June 2018 paper. Okay, so I'm going to do the same thing that I was doing previously to just work this out as if I were working this paper myself, and then I'll get to explain to you the answers. Okay, so enjoy the music. So on question A1, we asked to define the momentum. So the momentum of an object is the mass velocity product. Okay, so the product of the mass and the velocity of an object. If you say mass velocity product, you still get 4 marks. Okay, and I like the definition because it's very short, and you can also expound on it and to say it's the product of the mass and the velocity of an object. It's still fine. Then on the second part, you asked to define the inertia. So the inertia is the resistance of an object to change its motion state. So objects, they always have a motion state. An object at rest would want to stay at rest, and an object moving in a straight line at constant speed would want to stay there. That ability to maintain the motion state, it's called inertia. Okay, if you've traveled in a bus, sometimes the driver actually stops suddenly, and then you eject you eject forward a little bit. That's because your body has inertia. Your body was traveling at the speed of the bus, and then when the bus stopped immediately, your body wanted to actually proceed forward at the previous speed of the bus. Okay, so that's why this happens. And on the B part, you asked to state the differences between mass and weight. So normally, if somebody asks you your weight, usually they are actually referring to your mass. That's what we do in everyday life. But then in physics, it's different. The mass and the weight, they mean 2 different things. Okay, so the mass is fixed. So anyway in the universe, anyway the way you go, your mass is fixed. So if you weigh 50 kgs, you always weigh 50 kgs anywhere in our cosmos. Okay, and then the weight now, it depends on the gravitational field. So the Earth has its own gravitational field. Near the Earth's surface, the gravitational acceleration is steady, so it actually gives you a corresponding weight there. So the corresponding weight, it's according to the gravitational field of the Earth. But then if you were to go to the moon, then your mass would be less. So it would be your weight would actually be less on the moon. So the weight on the moon would be less, but then the mass would be fixed. Okay, so that's the difference. The difference is mass is fixed and it's the same anywhere in the universe. Whereas the weight depends on the gravitational field. Okay, so the weight changes according to the gravitational field. Then the C part asks you to state Newton's first law of motion. So Newton's first law of motion is also called the law of inertia, which is a term that we defined in this part here. So question 5a, item 2. So the law, it states that a body continues in its state. Okay, so that's what the law basically says. And then you also have to expound on what states you're referring to. So the state can be either of rest, okay, so the body is at rest, it's not moving, or it's moving at a steady speed, okay, it's moving at a steady speed in a straight line. And it continues to do this indefinitely. That means it will continue. If it's at rest, it will continue at rest indefinitely. If it's moving at a steady speed, it will continue to do that indefinitely, unless the body is compelled by an external force, okay? So if you push an object, you're changing its motion state. So yeah, so your body continues in its state, either of rest or at a steady speed in a straight line indefinitely, unless the body is compelled by an external force. Okay, so you have to recall this from memory: the first law, the second law, and the third law. Then on the B part, you are told that the body, a body of mass 0.4 kg accelerates uniformly at 2 meters per square second, and then you're asked to calculate the force of the ball. So according to the Newton's second law, the force of an object, it's equal to the product of the mass and the acceleration of an object. So in our case, you're actually given the mass, and you're actually given the acceleration as well. So you just calculate, you just multiply the two. So you multiply 0.4 here, multiply by 2, then you get 0.8 newtons. Okay, so that's just about it for this question. Make sure you like, share, and subscribe. Okay, in the next video. Yuba out.